Hi, everyone. I hope you're all having a great conference and enjoying your time hearing about all the great things people are doing with Google Cloud. Welcome to Dev 230. In this session, you're going to hear about how HCA Healthcare's work on building out a developer portal with Backstage has progressed. Here's a quick look at the agenda for today. I think we have a great talk, and I know that there's something here for everyone, no matter what stage of the platform engineering journey that you're on, or that your teams might be on. So, quick intro. My name is Paul Ravello. I'm a solutions architect here at Google Cloud. I work on platform engineering mainly. My team's mission is to make cloud easier. One of the ways that we are tackling that is by exploring different parts of platform engineering. Internal developer portals, different styles of automation, different ways of working. I'm very excited to be speaking here today with Cameron and Rowan. I think what they and their teams have been able to do at HCA is a real-world example of how applying platform engineering principles and methodologies can really help solve both business problems and just really reduce developer friction and cognitive load. Let's start at the beginning. I think based on the crowd here, everybody's probably familiar with Backstage to a certain degree, but what is it? It's an open source project that was started by Spotify and eventually placed into the CNCF. When you boil it all down, it's a framework that was specifically made to help build developer portals. It's not a developer portal in and of itself, but it's a framework that helps you build them. As such, it's really extensible and very customizable. Out of the box, Backstage includes a few main pieces of functionality. There's the software catalog, which is the main entry point into the portal. You have tech docs, which is there to provide you a really consistent documentation as code approach. There are software templates. They happen to be my favorite part of Backstage as a whole. They let you set up golden paths for your developers really simply and expose services that they might want to consume in a really standardized, easy to follow way. Plugins are there to allow you to take it to the next level and really deeply extend and customize the experience within Backstage for your developers and help you integrate with third-party systems, tooling, processes, whatever that might be. You might be asking, like, okay, that's all great, but what does that really mean for me? If you're a developer, Backstage can really help lower the cycles you spend on getting started developing. What I mean by that is, as a developer, if your company or team has deployed Backstage, hopefully it's configured in a way where you can go to that and have a smooth experience to get started on a new project, find the information you need, whatever it might be. As a platform engineer, Backstage helps jumpstart portal creation and really offers new ways of working to your teams, which is really cool, right? So as a platform engineer, if you're using Backstage to build out IDP, you're ahead of the game because the framework exists, the scaffolding exists, it's already all there. Anyone up and down the stack can really benefit from Backstage if you expose the relevant information to them through Backstage. Security, FinOps, you can create portals that really help get them the information that they need to do their job in a much more streamlined fashion. If you're installing Backstage on Google Cloud, there's a few built-in integrations you can take advantage of straight away out of the box. For user authentication into the portal itself, you can rely on native Google Cloud OAuth. And if you're interested in auto-discovering services that you've deployed to your GKE clusters, you can do that natively using a Google Cloud service account that you would configure. If you want to get involved with Backstage on Google Cloud, please, check out our work on GitHub, reach out to your account team, or reach out directly to me. And as always, remember, Google Cloud absolutely loves platforms. It's now my pleasure to introduce Cameron Farmer from HCA. He's going to talk about their platform engineering journey. Here you go, buddy.
Thank you, Paul.
system in the country and one of the largest in the world. We have 186 hospitals, 2,300 sites of care in 20 states in the UK. We see 47 million patient encounters each year. I have over 309,000 colleagues across multiple lines of business, and of that 309,000, over 7,000 are some of my IT colleagues, and about 1,500 of that is developers. We truly believe we're in a unique position to play a leading role in the transformation of care and value our strategic partnership with Google as we work together to continue to innovate on solutions that ultimately provide better outcomes for our patients. As a developer and a technologist of healthcare, that mission on the screen, above all else, we're committed to the care and improvement of human life, does not just apply to our medical and our clinical staff, but applies to me too. That's why it's important for us to find technologies and solutions that will reduce the bottlenecks around traditionally centralized IT, to accelerate software development, data science, and our data analytic initiatives at HCA, with the ultimate goal of focusing on improving the lives and outcomes of our patients and making it easier for developers. So let me get a show of hands. Who likes hiking? Anybody? I do too, but I am a very lazy hiker. So, this trail in Kailua, Hawaii, the Pillbox Trail. I like trails that have a little dirt path created by the ones before me. This one in Hawaii is a moderate trail, by the way, super fun, views are amazing. As a company, we had two very hard hikes to take at the same time. That was GCP and self-service to accelerate initiatives into the cloud. And the views were not as scenic as that along the way. What this ultimately meant was maturing how we architected and developed applications for cloud-native environments, adopting infrastructure as code, moving to containerization-first approach when appropriate, as well as putting enterprise-wide standards in place like CI/CD pipelines, prescriptive technology stacks, and tooling so that we can move faster and provide less cognitive load for our development staff. Today, I'm going to quickly share our cloud journey and how we matured our implementation of Backstage to accelerate us into GCP. Now, you might have thought this talk was going to be all about our technical implementation of Backstage. How do we do it? What was our secret sauce to leveraging the tool to accelerate into GCP? Well, we're going to get there, I promise. This will be probably one of the last non-technical slides you'll see. But the biggest part to our success with building our developer platform using Backstage was not the technology, but a multitude of cultural and organizational shifts to even allow Backstage to be successful in our environment. Over 2 years ago, about 1 year after we dived deep into our cloud journey with GCP, we were still struggling to get people onboarded and learning into Google Cloud. Why? We had no experience with GCP. Terraform, limited exposure to cloud-native development. We had a lot of manual processes, a lot of long lines of approvals with lengthy SLAs. We had distributed teams, making it challenging to align on the same goals in an appropriate time frame. We had standards, but not a clear path at scale for developers to learn and grow into GCP. So where did that put us? That put us at a long line of being able to not be able to get into GCP and get it to a point where we could be successful and get developers in there. Which leads us to our first use case with how we use Backstage. The first use case we developed with Backstage was tackling our enormous learning curve challenge that I talked about in the previous slide. Can we just get people into a playground, in our tenant, outside the VPC, no access to data? Can we get people in an environment where they can learn GCP services and infrastructure as code, then automatically tear it down, so when they're ready for non-prod and prod environments, they'll be skilled up and ready to go? Well, folks, we, the platform engineering team, were not immune to the learning curve. And after getting past deploying Backstage in our GCP environment, upskilling in infrastructure as code, and deploying Backstage into GKE and Cloud SQL for Postgres and Memory Store for Redis in our consumer projects, we identified that Backstage templates were where we needed to start. We needed automated, repeatable workflows to get people into GCP and learning Terraform. Our first template was the GCP Sandbox template. We designed the GCP Sandbox template to create IAM groups, create a GCP consumer project outside the VPC, and create a Terraform Cloud workspace with infrastructure as code, GitHub repo already authenticated to the workspace. We also created 5 custom actions in Backstage, as well as the creation of 3 internally developed wrapper APIs that interacted with our identity provider, Google APIs, and Terraform Cloud. So there we had it, GCP sandboxes. That self-service capability kicked off our rollout of Backstage to our developers, and boom, people were able to play and learn in Google Cloud. So there was happy devs. But wait, the main reason we were going to Google is to deploy real-world applications and solve real-world problems. While we had a win with GCP sandboxes and enabling people to learn, we only hit the top of the iceberg. But we were also in a prime position with what we built with Backstage to expand our capabilities even more. So we had an event last year on 4/20/2023, a very memorable date in the IT department at HCA. That was the day that 8+ teams with 5+ different SLAs got in a room with executive leadership and painstakingly still took 6 hours to get a non-prod GCP project within our VPC, spun up start to finish. Our leadership saw it, all the enablement team saw it, and everyone looked around and knew it was ridiculous that our own processes were causing these delays. The event was called Walk the Process. The outcomes of Walk the Process produced a workflow diagram outlining all the people and processes it took to get a non-prod GCP project, or what we like to call certified GCP environments, stood up. The biggest question out of that meeting was, how do we solve for the 60, 70, 80% of our use cases? It also led to teams like cloud, software engineering, containers, security, FinOps, all the people who turn everything on, as well as our product teams working more closely together. And with the organization making that people shift, it allowed for the solution that Rawan, one of our Google Cloud consulting engineers, is going to talk more in depth on how we continue to build on our success with Backstage templates into what we call certified environments. We reduced 1 month of approvals, 1 month of requests and approvals, to just merely 1 form and 20 minutes. And if you're in a certified environment for developers. So Rawan, I'm going to let Rawan come to the stage and show us how we did it.
Thanks, Cameron. Hi, everyone. My name is Rawan, and I'm a cloud engineer at Google Cloud Consulting, and I specialize around reliability engineering and automation at scale. I'm currently working at HCA as a resident architect. Before I joined Google, I wore many hats at startups, such as an SRE product manager. Then I transitioned to become a principal DevSecOps engineer at NASA. I started at HCA like a couple of weeks before I walked the process. And during that process, we focused on the data analyst persona's journey to get access to a project. But all of our HCA main personas, which is the developer, data analyst, and data scientist, follow similar patterns. So we decided to future-proof our design and ensure that we work on the commonalities and factor in the variances. But in this talk, I want to focus on just one persona, which is the developer. We're all devs here. So let's walk through the journey of how a developer can deploy an application to Cloud Run. Pretty simple, right? Initially, you might be thinking at a glance, well, that's easy. HCA already had the GCP sandbox template. All we need to do is add a custom action, invoke a gcloud CLI command or the API, and there we have it. We can deploy a Cloud Run service. Well, not so fast. An enterprise Cloud Run architecture looks more like this. And this is a simplistic view of a single Cloud Run environment. I've omitted a lot of the hub and spoke, connectivity to on-prem, the dev, QA, and prod, the elevation process, that should follow and elevate changes to upper environments. And this is one architecture pattern that HCA might adopt. There might need to be additional components to their infrastructure. So where do we start? Now let's visualize what a developer environment might look like without the application. And now, this is what HCA calls a certified GCP project. It's more of the foundation work. We have defined a pattern that fits our 3 personas with minor variances. For example, Vertex AI workbenches at HCA still require access to on-prem, as data sets live on-prem and in the cloud. Developers and data scientists need serverless connectors to deploy their serverless infrastructure, like Cloud Run or a Cloud Function, and a subnet for internal load balancers. HCA adopted shared VPCs to simplify network topology, but guess what? There's multiple spokes. And a project might need to be attached to the host network and connect privately to Cloud SQL and memory store. So this is a lot of information if we're expecting a developer to know who to talk to and figure out, oh, which spoke should I be connecting or inputting my Terraform in. So in this project, we decided to create our standardized environments via Terraform. And the reason is that management of dependencies is handled out of the box. It also does state management. So we're actually future-proofing our solution and not going back to calling APIs as per our original prototype. And any project that handles PHI and PII data, if you notice that yellow box that I depict there, is going to be inside a VPC serverless perimeter. And guess what? That means only trusted identities and origins can actually federate and authenticate to Google APIs. So if a developer actually selects a public GitHub runner or a cloud build deployment pool that is outside the perimeter or does not have access, they're going to get access denied. So this actually means that we need to provide our developers a full package to ensure that they don't get any permissions denied for highly regulated environments. If we look at what the custom actions that we provide here, these are part of what we've done on the walk the process, which is actually mapping out the manual processes that we have available, such as the way to get FinOps code. That was one person that had to turn the SLA within 24 hours to figure out who are we charging this project to. And it was like back and forth with questioning as well. So this was more, how do we eliminate the human out of the picture and decide to make our processes more automated? Okay, at a high-level approach, we start to streamline creating shell projects to provide more consistent user experience. But if you've ever written Terraform, what comes to mind is, how are we going to create projects and write something on a single input file, such as what we show above? Or maybe you can make it a little bit more simplistic, which is actually creating an input file separately and then creating a for each loop to actually traverse through Terraform. But when you have multiple project requests at the same time, committing a pull request to that repository, guess what will happen? Merge conflicts. And this is somewhat of a simplistic view of HCA's repository code when we reviewed it. So what we've decided to do is use Google Open Source Cloud Foundation Fabric version of Project Factory, which is similar. This is a simplistic version of what's there. And what this does is each project is actually defined by a single YAML file, meaning that if we have multiple projects, they're actually going to be separate files, which would eliminate our merge conflicts. I'm going to include the Project Factory version open source in the end of the presentation as a reference as well. You can extend this functionality to any Terraform module, for example, managing firewall rules or DNS records. At a basic level, all you need to do is loop the data in the files and store it in a map. Then create a for each loop for the module to traverse that map. An actual project creation will need a little bit more of a data manipulation after the fact, but it would look more like this. So when you actually create a project, all you have to do is define this YAML definition. You can enable API services. You can actually provision subnet IAM users, create service accounts, et cetera, and provide roles. And for anyone who has performed Backstage templates, you probably know where this is leading to. It's just fetch template with parameterization and a pull request. Now, we decided to also standardize on the repo structure to prevent human and input errors on guessing where to select the destination of the application infrastructure. And this is part of our promotion process. So when we talk about governed pipelines, we're talking about having branch protection to only allow feature branches or new infrastructure code to deploy first to the dev environment. So merely what we have is we manage variances with TFR files for each environment, and once we want to make changes in Terraform, you would create a feature branch that would create a PR to lint, scan, and plan the Terraform. Once it's done, you merge it to dev, and it will apply. We also include workload identity federation to allow keyless authentication. Once it applies to your dev GCP project environment and you do validation, you can merge those changes to QA, and it will deploy to the QA project and finally to prod. Now let's go back to our developer's journey. After requesting a developer environment via the template, they have their certified environment with a repository with the necessary fundamentals to deploy their application infrastructure. But now, how does a developer transition from this to an actual application architecture? Luckily, we have a template with this architecture pattern. So now the developer can go back to Backstage and fill out a couple of parameters by answering simple questions. And after navigating through the form and hitting create, the scaffolder will pull information from the service catalog on what VPC spoke to tie this service project to, other networking information, subnet IAM rules, and pre-fill the information on the developer's behalf, as well as fetching the repo that they will need to create the pull request to. And once the template completes execution, a pull request is created with the Terraform files and input variables needed to deploy the infrastructure and architecture in our governed CI/CD pipelines that we shared before. All we need to do is have the CI/CD pipeline scan, lint, create a security scan for the container as well, push it to artifact registry, and a merge would actually deploy the architecture. Okay, our happy developer has an enterprise architecture of Cloud Run by filling out 2 forms. I know that some of us think that we're done, but wait, there's one more missing piece of the puzzle. Now raise your hands, how many developers ever tried to deploy a new container through Terraform? Okay, that was the first attempt at HCA2. It's a little bit of a challenging experience, especially if you want to automate the CI and then the CD process to understand where to input that file. So we decided to use better tooling for deploying infrastructure that's separate of the application code. So we decoupled our application containerization, compiling, pushing to artifact registry, and deploying to Cloud Run from the actual infrastructure as code. And a high level, there's another template. This is the high level flow of that process. So we provide, HCA provides out of the box hello world code for 3 languages. We also, on behalf of the customer, will fetch the network system information from the catalog, install the CI/CD workflows, and templatize the Cloud Run service Knative spec. We decided to use Knative because it also mimics a deployment spec that you would use in Kubernetes, which means there's a seamless transition between Kubernetes and GKE specifically and Cloud Run. We then published the GitHub repository with the branching strategy, secrets, and variables. Finally, we provide workload identity federation access tied to actually the repo ID to ensure that a developer will unable to rename the repo or delete the repo and create a new one, and it will prevent from any type of federation on that behalf. It's also restricted to the trusted GitHub organizations at HCA. Once this process completes, the developer will have a repository with a sample code. The pull request would actually secure scan, lint, and compile the code, push it to build the Docker container. Once that happens, it pushes it to artifact registry. And then finally, CD will actually deploy to Cloud Run, to the dev environment as well. So if we want to summarize the developer journey, it takes about 20 minutes to run the first shell project, which is a certified environment. Another 10 to 20 minutes to actually deploy the application infrastructure. And then finally, codifying and compiling and creating the container for the code is another 20 minutes. So we shaved off like around a 2 to 3 month process into 60 minutes. Pretty neat, right? Now let's look how the experience looks like from the developer portal. Cameron, over to you.
Awesome, thank you, Rowan.
Water.
So this is our developer portal built on top of Backstage. These are the 3 templates that Rowan just shared some of the underlying automation and architecture deployment or architecture patterns. And so I'm going to do a quick demo, or we'll do a quick screen. I'll show you how this works in fast time, because we all don't want to sit here for an hour. So we'll start with creating a dev GCP project. We'll call it Next Demo. We'll give it a description. We have multiple lines of businesses that are tied to shared VPC networks. Choose a GCP region. We have the ability to add additional owners or members to an AD group that is bound to the project. And that's it. We'll kick off the template. We're fetching a lot of underlying information based on the answers the user selected, such as shared VPC, ILB subnets, which are resources in the catalog, and information that gets passed to the infrastructure as code automation. We're creating Terraform workspaces. We're creating AD groups, creating info repos, documentation files, branching strategies, and then creating the PR. There's the info repo for the product. Next is the Terraform workspace. And then the GCP project, which in real time took approximately 1 minute and 30 seconds to run, but with AD group syncing, it takes a total of 30. So our next step will be to run the template for creating Cloud Run infrastructure. We'll choose our system that we just created from the catalog, which is synonymous for the product name. We'll use an internal load balancer to handle the traffic. We'll give our Cloud Run instance a name, call it Next Web. We'll enable SQL. We can enable SQL access, but we won't for this demo. We can enable identity-aware proxy, offer the ability to do custom URL routing. We aren't enabling Cloud SQL, of course, or attaching a storage bucket in this example, but we do make it available to our customers, and it's kicked off. Again, we're fetching all the parameters needed to pass on to a PR on our info repo that we created in the last step, lines of business, shared VPC, identity-aware proxy. Here's the PR with the updates to TF-vars and variable files. The GitHub action will do a plan and apply to TF Cloud and get the infrastructure deployed. So the last part, setting up CI/CD for app deployment, application code deployment. We're going to give the developer standardized CI/CD pipelines with Knative YAML for deployment.
Still on the next right now.
And we'll choose that template. We'll choose which environment we're deploying to. We'll select our product. We'll select our GCP project, select our region, specify the service name, describe the service name for the developer portal, choose AD owning group, define your component type for the catalog, create your host name for the site, select your language for the Hello World app deploy, and we'll review and create. Here we're fetching networking, our standard CI pipelines for deployment, the Hello World code, creating a repo for the code base, setting up workload identity federation, adding Canary deployment workflows, and that'll take just a little bit longer. Talk too fast on the first slide, talk a little bit less slow on the second one. All right, we'll approve and merge that PR. GitHub Actions will kick off the deployment. And when that deployment is done, then we have our front-end application. So there we have it, a GCP project with a front-end Hello World application deployed to Cloud Run with all of our standards in place. So I want to quickly recap our journey and then shed some insight onto kind of where we're headed with our developer portal at HCA. So we started our journey back in October 2022, proving out Backstage with a single developer. That team expanded as we ramped up development efforts for releasing our GCP Sandbox template in March of 2023. After releasing Sandbox, we had the Walk the Process effort, our cloud platform, developer platform, FinOps, IAM and security, cloud operations, Google, as well as our Insight partner, started to collaborate more closely together to deliver self-service to our organization quickly and at scale. July 2023 is when we released GCP project provisioning, cutting down the provisioning time to about 20 minutes, like we just showed. In October, we released the Cloud Run capability package that we showed in this video, as well as our data science environment. And just last month, we released our GKE onboarding capability package as well. We're currently working on streamlining our process, our product and application lifecycle management to be within our developer portal, as well as integrating AppleGX, spending some time expanding the capabilities of our service catalog to be more robust. We have more Golden Paths that we're scheduled to be released this quarter and into the next, and we're working as an organization to deliver data products and pipelines even quicker to our users. That's a lot of work. We are hiring, by the way. A couple of things I hope resonate with you today. Backstage templates can be powerful. They provide the ability to create golden paths and reduce the cognitive load that a user would only have if reference architectures were provided, speeding up the time to hello world and the cycle time to production. Developer experience should be your #1 focus. Treat your platform as a product. Find your use cases, incorporate different perspectives and expertise, release frequently, get feedback from your users, keep iterating and improving the platform to provide the easiest path for developers to stay in the flow. Automation promoted our personnel to higher level roles. And I guess it's not news, but AI and automation is not here to steal our jobs. We talk mainly about our enterprise offerings, but that's a lot of work. Our platform teams, but a lot of our platform teams also create templates in the developer platform for some of their repetitive tasks, providing the capacity to work on and learn other things, also giving our platform teams opportunities to solve harder and more complex problems.
So that's about it. I did include the references, especially the Project Factory one, if you want to do like more YAML-based development. You can also leverage this capability for more your ops team to actually onboard new customers. It doesn't necessarily need to live in a developer portal. There's references about how to write templates, custom actions. There's a simple Cloud Run deploy template for those who are novice in Backstage. It has step-by-step instructions there, and a simple, just get your feet wet on this. And there's a blog about how to run Cloud Run CI/CD pipelines through GitHub Actions if needed.